Alright, here we go. Okay, so slope is rate of change in same slope. So you can hear it all these different ways. Okay, so it's called rate of change. It's called slope. It's the m variable. It's called delta y over delta x. This means difference of y over difference in x. You'll hear it as rise over run. And then this last one is the slope formula. Okay, this is how you find slope given 2 points. Okay, so that's the slope formula. Okay, there's also one more way I'm going to give it to you. Okay, so we give it to you as the change in y and the bottom is going to be change in x. Okay, so get that in your notes. These are all different ways you'll see slope. We're going to work with these boxes. Okay, we work with rise over run. We work with m, rise over run, and the slope formula, and then we work with this over here. Okay, you'll see those 4 different things. Okay, so when we find slope, okay, it's a function for linear functions and shows a constant rate. What that means is when you find slope of 2 or something like that on one of the lines, that slope stays the exact same slope throughout that whole line. It's constant. It doesn't change. If the slope changes, you have a new line. Okay? So the slope, if you find the slope of lines to be like 3/2, then every part of that line will be a 3/2 slope. Okay? Alright? So, we're going to also show you how to convert from standard form to slope-intercept form. This is not a hard conversion. You've done this many times. Okay? Believe it or not. And we're going to talk about horizontal lines and vertical lines. Horizontal lines, folks, have a slope. The rise is 0. That means the 0 is on top. Be like this. The 0 is on top of the fraction. That means the slope is 0. 0 divided by any number is 0. So this slope is 0. Okay? For vertical, and these are horizontal lines. Okay? Vertical lines, which look like this. Okay? Their slope is on the bottom. Their 0 is on the bottom. So they have like 7 over 0. Okay, when the slope when you have a 0 on the bottom, or the run is 0, okay, you can't divide by 0, so this slope is undefined. Okay, so we call that undefined slope. Alright? Okay, now, to find slope, we got to do a couple things. Okay, if we're looking at a graph to find slope, first thing we're looking at, the very first thing you do, you decide if this is positive or negative. Okay? Okay, here's what we do. We look at the line and we say positive slope, they go up to the right. Okay, negative slopes, they go down to the right. So we look at this line. Is this line going up to the right or down to the right? Anybody know?
Upright.
Okay, so this is a positive slope. Okay, decide that before you do anything else. Decide the line is positive or negative. So this slope is positive. Now we're going to find the slope. And we're going to use what they call the triangle of understanding. Okay, so we're going to make a triangle out of this. So we draw this triangle right here, go straight up and straight across. There's the triangle of understanding. You want to count the rise, which is right here, and the run, which is up across top. Okay? So the rise and the run. That's how we find our slope. Okay, the rise, do not count the first point. This is where you start at 0. So you're here, you go count steps, you go 1, 2, 3 steps up. So my rise is 3, so I put my slope as 3 over, and my run is on the top, the run right here. Again, don't count where you start counting, but just count the steps, so it's 1, 2 steps. This is a 3/2 slope line. Okay? That means anywhere I go on the line to count points, if I go down here to count them, I'll go up 1, 2, 3 over 2. I get back on the line again. It's going to be a 3-2 line no matter where I count it from. That slope is going to be constantly 3 and 2 all the way up that line. Okay? All right, now a couple things about slope. As you're counting slope, you're going to get into a couple situations. You're going to find yourself with like 12 over 8. Okay? Well, reduce this down. Okay? Make this become 3 over 2. So reduce all slopes down to the nearest thing. Okay? So all slopes will be reduced. Okay? If you have one that ends up like 18 over negative 18 over 6, this goes down to negative 3 over 1, or just negative 3. So it comes up to a whole number. Your final answer should be in whole number format. We realize that it's 3 over 1, but for a final answer in slope, we want the whole number, not a fraction. Okay? All right? That makes sense? So reduce all slopes down to the lowest case, and if it goes to a whole number, put it in whole number format. Okay? Any questions on those? Okay, so number 2 here. We do number 2. We find the slope using 2 points. This is where we use our slope formula. Our slope formula is the one right up here. This is our slope formula, okay? So to use our slope formula, we write it down right here. We go x, y2. Y is always on top. Okay? How come the y is on top? Because that y controls the rise of the graph. And it's always rise over run, okay? So now we look at our points, and we count this point as x, first point, y, first point. These are just names. They're just labels. They have no mathematical value. They're just helping us organize things. This is x from the second point. This is y from the second point. Okay? So when I do my math, I go over here and I find the y from the second point. It's negative 1, so I put it down right here. I always subtract between the 2 points, so I put a subtract. Then I go get y from the first point. Y from the first point is 8. Okay? Then the bottom. It's the x from the second point. That's a 3. Again, we always subtract. And the x from the first point is a negative 2. So this subtracts a negative 2. Okay? Now do the math. We have negative 1 minus 8. That gives you negative 9. If you have 3 minus negative 2, when you do a minus negative, that becomes plus. So 3 minus negative 2 becomes 3 plus 2, and 3 plus 2 is 5. The slope will not reduce, therefore you are done. That's your slope right there. Okay? Are we okay with that? So you use the slope formula. You have these 2 points. This is the slope formula. Okay? Label these points. x1, y1. The 1's come from the same point. The 2's come from the other point. And then we just put them in the formula where they go and do the math. Okay? Right? If you have to use a calculator to do this, I don't care. So if you have negative 1 minus 8 and 3 minus negative 2, you'll get those numbers. Okay? Any questions on that? Okay, maybe later I'll show you a different way to do that, but I want you to do it that way right now, okay? And I put the slope formula on the wall over here for you. I changed the poster so you can see the slope formula right there in front of you. Great big old thing. Okay? All right, these next 2 are kind of the same, but they're kind of different. So let's see what they look like. We're going to graph, okay? Now the first thing to do is they tell us to use the slope of 2/5 and the y-intercept of negative 3. Now we've done this before. We know how to graph this. We did this on Monday, so this shouldn't be bad. But so we go to find this intercept slope. We drop down to our graph. We find our negative 3 intercept, means we go down 3 steps on the y-axis and put a point right there. Okay? And then we go to our slope, and we go up 2 over 5 for our next point. This is positive slope, so we rise up and run 5. So we rise 2, run 5, puts our points like that, and we hook them together. Okay? Now, I want you to remember, though, that this intercept point, just because it says it's negative 3, the actual point of the graph is 0, negative 3. So that point of the graph is right there. That's going to come in really handy in just a second here. So even though they give us the intercept point, the point of the graph is a 2-coordinate point, has an x and a y value. Okay? Now, on the next one then, on number 4, they do the exact same thing, except now they give us a different starting point. So they give us a slope, but now instead of an intercept, they tell us a starting point. This is just a point on the graph to start. Okay? That's where you start at. So to find that point, we're going to go 2 to the right and 5 down. So go 2 to the right and go down 5 steps. There's your starting point right there. Okay? That matches your starting point. And then from that point, run this slope. Okay? So the slope is down 1, right 4, down 1, right 4. Okay? So they may start you off the intercept somewhere. So the starting point is just a point on the line or on the graph somewhere that starts at. So you just do the x first. X is left and right. So I go right 2, and then y is up or down, and I go down 5. That's why I went to that point. So I right 2, down 5. There's my new starting point. And I just go to my slope, and it goes down 1 over 4. Okay? And I get my line. Now, so the only difference in that is where the starting point is. Okay? So on this one here, the starting point was the y-intercept, but that point was still 0, negative 3. Now we just have a different starting point. We have 2, negative 5. It doesn't really matter. We're still the same way. Okay? Just have a different starting point. That make sense? You okay with that? Okay. People get lost on this because they don't know where to start. Well, let's just go start there. Okay? You don't always start at home, do you? When you're going somewhere? If you go to the store from here, you're not starting at home, are you?
Yeah.
So you have starting at school, different starting point. Okay? All right, who's leaving? Okay. All right, we'll get those in a minute. You got a whole bunch? Whoa, dude. Okay. All right, I don't know. We'll figure them out in a minute. Okay, last part. Okay? Now, this is how we changed from standard form to slope-intercept form. Okay? But believe it or not, you've done this a number of times. Okay? I would dare say you've changed an equation at least 100 times by now. Alright? So, the only difference is, okay, standard form is ax plus by equals c. So this is standard form. My a is negative 6, my b is 3, and my c is negative 15. Slope-intercept form looks like this. Y equals mx plus b. So the only difference is I got to solve this equation for y. Okay? So to change an equation to slope-intercept form basically means solve for y. Okay? So we're going to solve the equation for y. So drop your line in there. Find your y. That's the variable we're leaving alone. So go over here and get rid of the negative 6x. Get rid of negative 6x, you add 6x to both sides. Okay? And remember, these are not like terms. They cannot be added together. All you can do is write them next to each other. So the 6x is gone. I have a 3y right here. Equals. These are not like terms. Do not add them together. Do not subtract them. Just rewrite them. So we want to put first. The 15 and the 6. Huh? You want to put the 6 first? Okay, then we get 6x minus 15. Okay? If you want to put the 15 first, I don't care. So if you want to write it like this, you have 3y equals negative 15 plus 6x. I don't care which way you write it. Okay? Doesn't matter to me. Doesn't matter to Sam, doesn't matter to Math Man, okay? Go back to your variable you're solving for, and you gotta get rid of this 3. What's this 3 doing? It's showing times, right? So to undo times, we divide by 3, and we divide each term by 3. Okay? So I get y, 6 divided by 3 is 2, so I get 2x, and negative 15 divided by 3 is negative 5. I'm in slope-intercept form now. Okay? Guys, this is a skill you need to learn. This is a critical skill. Changing from standard to slope-intercept form is something you're going to do a lot in your lifetime through your career in high school and college. You'll do that many, many times. Okay, it's a really simple skill to do. Okay, if you do it this way, yeah, you divide by 3 both sides, everything down here, and you get y equals -5 plus 2x. It does not matter, because we're looking for the slope. Okay, we're looking for the slope of the intercept. Remember, if I find the x, I find the slope. Doesn't matter if it's first or last, doesn't matter. I can still find the slope. My slope is going to be 2. Okay? Again, for answer purpose, put 2. For graphing purposes, 2 over 1 to graph it. Okay? The y-intercept is -5. For graphing purposes, is 0, -5. Okay? We go find that point. 0, -5 is right there. Once you find the point, go up 2 over 1. There's my line going up that way. Okay? Once you get going, you get a pretty good pattern going here. There's your line going down through there. Okay? All right. Okay, one last thing. This is off note. So you got to put it on your back. Okay? Linear equations have to look like this, okay? Gotta get down here so you can see it. Linear equations gotta look like this. Y equals mx plus b, or ax plus by equals c. Okay? You look at these really closely, you'll see there are no powers. There are no powers. Okay? There are no fractions of variables. Like 7 over x or something like that. That's x. 7 over x. There's no fractions of variables. Okay? That's how you can tell if something's linear. So if they're asking a question about, hey, is this a linear equation? I got y equals 7x squared minus 9. The minute you see x squared, this is not linear. Linear has to be in this format. Something looks like this. No powers, nothing else like that, okay? All right? Okay, if you're not sure, graph it. If it comes up a line, it's linear. If it's not a line, it's not linear. Okay. The power, no powers are allowed. So if I have like y equals x, that's linear, because it looks like this. Okay? Then like that, no. And then you throw a power there, it's not linear anymore. Okay? So no powers allowed at all. Okay, linear has to have this right here only. Okay? Alright, go to work. Guys, we're out of this class at 10:43. You have 23 minutes to work. 1, 2, 3.